Welcome to another traveling microbiologist adventure. This time we're gonna explore GIDEON Diagnostics. It is a very amazing database that is advancing the global effort against infectious disease. And you will see how many different options we have to understand infectious diseases. What we will do, we will right now use it to identify our unknown organism. If you are at UF, you can either log in directly if you're on campus, or you can use your VPN and then sign in. It should recognize you through the University of Florida. And to identify our organism, we will go to the lab button, we will go to bacteria, and then we go to the probability engine. You probably recognize from many of you have taken microbiology lab probably before, and you see the dichotomous tree, but I think that's a little bit outdated and old-fashioned. So we're going to use our probability engine, where we can just add the results what we have done in the lab to get our unknown result. Alright, let's find a wonky organism and let's get going. I think we're okay, we don't need help. Let's do a gram-positive, and again stick to the positive results, because not all organisms are always positive or negative. So if you start with the positives, the algorithm behind this machine is doing much better. So it's a gram-positive organism. It is a bacillus, and yes, it forms spores, which we saw in the gram stain. It is motile. It doesn't have a yellow pigment. It did not grow in the anaerobe chamber, so we call it anaerobe. And it does grow in blood agar. It doesn't grow in McConkey agar. Let's do this. It's negative. We don't know about this because the growth in 6.5% sodium chloride is our mannitol salt agar. It did not grow there, but we're just going to leave it out. It is oxidase positive and also catalase positive. And it did have beta hemolysis. Our DNase was positive as well. And so we go down again. There's lots of different tests. Our glucose was yellow. Our citrate, was it positive? Yes, our citrate was blue as well. Turned from green to blue. And I think that's pretty much all the tests we have. So we have with a really high probability, we have Bacillus subtilis. And let's go up. So it's a gram-positive bacillus, spore-forming, motile, aerobe, growth in blood agar. It does not grow in McConkey, oxidase catalase positive, beta hemolysis, DNA looks fermented. So it's a really high probability that it is Bacillus subtilis. So I think we're doing a pretty good job. Let's see if it makes sense, because we got it from the environment. And let's see what it says. Associated with food poisoning infection, we know that. And oh, that's interesting. It's one of these ones is variant natto, and I'm not sure if you know that, but natto is actually a fermented food in Japan with soybeans. So you cook soybeans and then inoculate it with the bacillus spores, and it becomes this gooey mass, but it produces nattokinase that is actually really good for blood clots and other heart conditions. So people in Japan eat it all the time. Side note here. Alright, so Bacillus subtilis, small rod, slender. It looks, our gram stain looked like that as well. So I think we have a pretty good chance. So I want to point out this little graph and identification here. So it says always, mostly, and not always, or never. So the one thing what I want to point out in microbiology is things are really not black and white, because not all microbes are always one thing or another. Yes, they're gram-positive or gram-negative, they have certain characteristics, but some characteristics are just not typical. I recently identified with our diagnostic mass spec, I had 2 colonies on a plate. One was white and the other one was bright yellow. The gram stains of both looked like Micrococcus luteus because they were arranged as a tetrad, 4 organisms stuck together. So the gram stains look exactly the same, but the morphology wasn't. And when I used my diagnostic mass spec, both of them turned out to be Micrococcus luteus. And it's very uncommon to have a non-yellow Micrococcus luteus. But I just want to put that in front of you, that microbiology is not black and white, and you get lots of weird things and different organisms behaving in different ways. So just on a short note, that the phenotypic characteristics of organisms are not always the way you think they may be, or the textbook says. So always challenge, question yourself, ask behind, and don't always believe what's written down.